All right, factoring is our topic du jour. And this is where a lot of people start struggling in algebra, is the idea of factoring. So most people are just fine with this whole multiplying deal. All right? Most people are just fine with multiplying and foiling and stuff like that. They get that. It's when we have to work it backwards that we have problems. Now, a couple big things we're always looking for in factoring. First, whenever we have a factoring problem of any sort, is greatest common factor. We always look to see, to start with, if there's some sort of greatest common factor we can take out of all the terms. And it has to be for all the terms. If there are 5 terms in a polynomial, that has to be the factor for all 5 of the terms, if it's just going to be greatest common factor. It's distributive property backwards, basically. So if I have something like x squared minus 3x, what do they have in common? What's their common factor? Just x. And if I factor that x out, which remember factor means divide, so it's like we're dividing everything by x, what's left after that division? X minus 3. Okay, because the x squared cancels the x, and that cancels that. That's why factoring is like division. And greatest common factor is usually easy to check because if I redistribute, I should wind up with what I started with. Now, I always get 1 or 2 people who factor it out and then go, oh, that's distributive property, and put it right back to where it started. Okay, not so helpful. Okay? Because remember, the idea here is just to take it apart. How about here? What's the greatest common factor here? 3x squared. Good. Okay? Because 3 goes into both 6 and 9, and there are 2 x's in each term. So if I factor that out, and again, sometimes for some people it helps to do this little writing it down. You don't have to, but it helps people see what's there. 6 over 3 gives me a 2. X cubed over x squared gives me an x. Minus, what's going to be left? Just 3. I know a lot of you don't need that. You've done this enough that you're pretty good at it and you're pretty comfortable with it. But always look for greatest common factor first. The biggest problem people make in factoring problems is not doing that, and then they get a factoring situation that's much more difficult than it needs to be. Boy, I didn't put my Aunt Cans up today. I erased the board and watched it and everything. I didn't put the new ones up. I'm sorry. Your I can statement today is I can factor polynomials. If you want to, you may, yeah. For geometry. There we go. I don't want you to miss, knowing what it is you're going to learn about today. I realize if you come to the board and you don't see what you can do today after today's lesson, that you probably feel lost and alone. And you probably want to just curl up and cry. But maybe I'm hoping this helps a little bit because it gives you direction. No? Okay. I'm sorry you feel that way. That's nice. That's great. Is his name Daddy Warbucks too? Yes. Okay. Factoring polynomials in the form x squared plus bx plus c. Now, we're breaking factoring into 2 days. Today we're looking at this with the leading coefficient 1. So there's no number in front of the x squared. This is the easier factoring. It's a little more complicated if I put a number in front of the x squared. We'll do that tomorrow. When the leading coefficient is a 1, the factoring is simple. We use the product sum and try to find the magic numbers. Okay? Basically, I need 2 numbers that give me a product of whatever this is and a sum of this value. So in this case, I try to find 2 numbers multiplied that give me a 15. Product equals 15. Sum equals 8. 3 and 5. Okay? Product must be 15. Sum must be 8. So the magic numbers are 3 and 5. So the factors of this polynomial, therefore, are x plus 3, x plus 5. And so it works really easy. when we have this, because once I find those magic numbers, I also have my factors. I don't have to do anything else. As soon as we put a number in front of x squared, this doesn't work the same way. We still have to find magic numbers, but then there's a whole bunch of stuff we have to do after. Grouping and a whole bit. And we'll talk about that tomorrow. But for now, we're always happy when we start out with an x squared. That's our first term. Let's look at the next one. X squared minus 3x minus 40. The product must be negative 40. Good. We caught the negative sign. And the sum must be negative 3. Now, we can get some clues from this. Okay? Since the product is negative, okay? Since the product is negative, what does that tell us about the two numbers we're looking for? The only way we get two numbers, what do we get, Jared? Okay, but before we even find what the exact numbers are, what does it tell me about the nature of those two numbers that we're going to have to look for, since it's, one has to be positive, one has to be negative. Yeah. Because when I multiply two numbers and get a negative product, the only way that's going to happen is if one is positive or one is negative. They have to have different signs. So immediately I know I'm looking for numbers with different signs. And negative 8 and 3 happen to be it. And since the sum is negative, it's the larger number that has to be the negative one, right? If I had positive 3 as my second term, then it'd be positive 8 and negative 5. But it's negative 8 and 5. So x minus 8, x plus 5. How about here? X squared minus 8x plus 16. Product has to be positive 16. The sum must be negative 8. Now again, this is telling me something. And I know you've probably got the numbers already. But since the product is positive, the two numbers must have the same sign, but they might not both be positive numbers. In fact, since the sum is negative, that's telling me that both numbers have to be negative numbers, right? So as I'm looking, it gives me clues as to where to look. And those two negative numbers are, obviously, everybody said, and negative 4. So my factors are x minus 4 times x minus 4. Or if I want to write it, I can write x minus 4 squared. Because it's x minus 4 times x minus 4. Anything times itself is that thing squared. You remembering how to do this stuff? Yeah.
Okay, so I'm kind of confused on how you find the magic numbers. Like, do you just multiply to add up?
I just start thinking, okay, what numbers multiply to give me 16? Well, 1 times 16. 1 plus 16 is 17. Didn't work. Okay. 2 times 8. 2 plus 8 equals 10. Nope, not a negative 8. 4 times 4. 4 plus 4 equals 8. Oh, but if they're both negative, then that'd be negative 8. There we go. Now we found it. Okay. So basically, we just kind of go through with our experience on just our times tables and stuff like that, figuring out what are the factors, and then getting it to be pick the factors that give the sum. Yeah. Oh, this is the product, and this is a sum. Okay, and the product always comes from this number. That gives me the product, and this number is the sum. Okay? So a couple more. X squared plus 10x plus 9. Again, the product must be, the sum has to be 2. Wow. That's all I got to say to that. Wow. Okay. What two numbers multiply? Give me 9 and give me 10. 9 and 1. So 9 and 1 are my magic numbers. This is x plus 9, x plus 1. Product has to be negative 45. Sum has to be two numbers multiplied to give me negative 45, add to give me negative 4. Negative 9 and 5. Because negative 9 times 5 is negative 45. Negative 9 plus 5 is negative 4. Again, how do we come up with that? It's a guess and check thing. And what numbers multiply give me 45? 1 and 45, no. 3 and 15, no. 5 and 9, ah. So x minus 9, x plus 5. There's a couple special patterns that exist, and we can memorize the special patterns, especially the perfect difference, perfect squares. It's a great one to recognize because it factors so easily. We can do it with the ABC. I mean, I could look at this x squared minus 49 and say that's x squared plus 0x plus 49, or minus 49. Okay? And then my product has to be negative 49, and my sum has to be 0. Well, the only way I get a 0 sum is if the numbers are the same number with opposite signs, right? It's the only way I can get a 0 sum of numbers like that. So what two numbers multiply to give me negative 49 and give me 7? Positive 7 and negative 7. Okay? And what do we notice about this? X squared is x times x. Negative 49 is 7 times negative 7. Whenever I get a difference of perfect squares, it always factors like that. Okay? So I can do it through the three-term thing, or I could do it through just memorizing the pattern. And the pattern is this. It's written down here. That anytime I have a squared minus b squared, it's always a plus b times a minus b. That's our pattern. And it's a good one to know and to have memorized. So if I have x squared minus 121, what's the square root of 121? 11. So this is going to be x plus minus 11. This only works with this particular pattern, okay? If there's a middle term in there, if there's like a plus 3x or a minus 2x or something like that, or plus 865x, I don't know, whatever, we can't use this pattern. It only works with this specific pattern. A little more tricky, 4x squared minus y squared. This is a perfect square, this is a perfect square. So what square gives me 4x squared? 2x plus minus and then a y. How about 25x squared minus 64? 5x plus and minus 8. Okay, so we can factor some pretty kind of nifty things using that pattern, as long as it fits that pattern. Now, if I get something like x squared plus 16, it's not going to factor in. Let's see what happens with that if I try to do that. If I try to do that, x squared plus 16, let's say I set equal to 0. I want to solve that. That's x squared equals negative 16, so x equals plus or minus the square root of negative 16. Oh dear. How do I take the square root of a negative number? Well, until algebra 2, you don't. That's a no solution for now. Algebra 2, we actually will come up with a solution for that. We're going to call that plus or minus the square root of 16 times the square root of negative 1. Square root of negative 1 is a number we're going to call I. I just did. Okay? That's what you learn in Algebra 2. We aren't going to hold you accountable for that now. But the square root of negative 1 is a number called I. Square root of 16 is 4. Square root of negative 1 is the number I. It's called the complex unit in this complex number system. So something to look forward to for next year. Yay! I. Numbers that are letters. Woo-hoo. We already did pi. So it's a Greek letter. No, Pi Day is tomorrow. I'm not sure in which universe you live, but March 14th is tomorrow. No. You can always bring food to class. Okay. And for anyone who's, thinking about, Perkins French silk is always a personal favorite. Okay, now, solving equations. The next natural step here, because factoring this is fairly simple, the next natural step is actually going ahead and solving these equations. In other words, up to now, all we're doing is factoring. We're never solving. It's not equal to anything. These are not equations, these are expressions. The difference between expression and equation is expressions don't have equal sign, equation, equal, have an equal sign. Okay? So if we have an equation we need to solve, x squared minus 7x plus 12 equals 0, we solve it by factoring. We factor it, and again, this is a pretty easy one. Product is positive 12, sum is negative 7, so that's negative 4 and negative 3. So that's going to equal, so that product equals 0. Now, this is the part that a lot of people get mixed up on. They think the magic numbers we came up were negative 4 and negative 3, right? Those are our magic numbers, as we refer to them. And our factors are x minus 4, x minus 3. The solutions to this equation, however, are not negative 4 and negative 3. Because what we're saying here is x minus 4 times x minus 3 equals 0. And whenever we multiply two numbers together and the product is 0, it means one of those two numbers must be 0. If a times b equals 0, then either a equals 0 or b has to equal 0. It's the only way we get a 0 product. It's called the 0 product rule, actually, in algebra. Strangely enough, multiplying 0 to get a product of 0, it's called the 0 product rule. I don't know who came up with that crazy idea, but that's what it's called. So that means that either this equals 0 or the x minus 3 equals 0. Solving them separately, which is not a great challenge, x equals 4 or x equals 3. So my solutions to this equation, and there are two of them. Why are there two solutions? Because an x squared equation, an x cubed equation would have how many solutions? 3. An x to the fourth equation would have how many solutions? 4. Okay. That's something called the fundamental theorem of algebra, which you'll learn about in Algebra 2 also. But we found this, but we can actually solve the equations. And you'll notice that the solutions are the opposites of the magic numbers. Now, the solutions are often sometimes referred to as the zeros or the roots, or zeros or roots of the function. Okay? Those are different words we use to describe the solutions, are not the same things as the factors. They are related to the factors. We get our solutions from the factors. But the solutions and the factors are not the same thing. Like I said, they're closely related. And factors give us solutions, or factors give us roots, or vice versa. But they are not the same thing. So our magic numbers are not our solutions. The magic numbers are not our roots. They give us, magic numbers give us factors. Factors give us solutions. So let's put this into practice. X squared minus 5x minus 36 equals 0. Again, we're going to start by factoring. We're going to ignore the equals 0 for a second and just factor. My product has to be negative 36. My sum is, what, two numbers? Well, negative 36 could be 6 and 6, 9 and 4, and how about negative 9 and positive 4? Okay, so negative 9 and positive 4 are my magic numbers. So x minus 9, x plus 4 equals 0. And what number would make this 0? Well, that would be a positive 9 and a negative 4. Those are my solutions. And that's actually just the opposite of my magic numbers, right? Okay. Now, I don't want to get hung up on it's the opposite of the magic numbers, because that's not the way it is when you start putting a number in front of the x squared again. Now we got a whole new set of rules. But the idea of what value of x makes this factor 0, what value of x makes this factor 0, that's going to help us. All right? How about 5x squared minus 30x equals 0? Oh dear, that doesn't have a leading coefficient of 1, does it? When it doesn't have a leading coefficient of 1, what should we look for? Something that might help us would be a greatest common factor, maybe? Is there a greatest common factor there? Yeah. 5x. And I'm left with what? Oh, I don't even have anything to factor using the product sum rule, do I? No. Nothing there to factor. So so this is another reason why I want to do this. Obviously, what would make this one 0? What value? 6. What would make 5x equal to 0? What value of x? 0. So my solutions for this one are x equals 6 or 0. Are we having fun ripping our little pieces of paper and making a sculpture? It looks like some sort of sculpture. Yeah. It's a nest. Yeah. Are we laying eggs soon? It is springtime. Time for birds to lay their eggs. Okay. So again, factoring, solving. Those are the two things we're looking at. We're going to do this today with these type of polynomials. Tomorrow we're going to look at it with polynomials with leading coefficients in front, a little trickier. But practice this stuff. Again, it's another worksheet. Yay. And the answers are actually on the back this time. So on one of them, on number 22, it cut off the equals 0, but I think you can figure it out. Blah. There we go. So the front page is just factoring. The back page is actually solving. But practice this, because again, useful stuff. Very, very useful.